am back for the Senior 2 class. At this moment, we have studied a lot. At BAC Science Education Consultants, I am teacher Agawa Kosma. We are continuing with Senior 2 Physics. We have been moving with the journey studying about pressure. Remember a few things, that pressure is a force acting normally per unit area. Remember lesson 1. And remember we said that the SI unit is a Pascal, PA, or a Newton per meter squared. That was coming from pressure equivalent to force out of area. That pressure was equivalent to force out of area. That is the general formula for pressure. We moved on and we calculated pressure exerted by solids using pressure equals force out of area. Now we have moved to pressure in liquids. Pressure exerted by any liquid. We are used of liquid, we know, water, alcohol, very many. Somebody told me soda and others. Those liquids, they have different densities. We shall see something. Do they exert the same pressure? In other words, which factors does pressure in liquid depend? Our topic is to show that pressure is equivalent to H rho G, where H is the depth of the liquid, rho is the density, we are used to this, and G is the acceleration due to gravity. That is what we are doing today. Let's go. We shall move from pressure equals force out of area, and we see how we arrive at that. We are considering a liquid. Consider a liquid of density rho in a container to a depth H as shown. So this is our cylindrical liquid up to a certain height H. This height is H. So how do we get pressure? Pressure equals force out of area. What is force? But force equals mg. So what is pressure? Meaning, when I get where there is force and I put this mg, therefore pressure will be mg out of area. What is the mass of this liquid? What is the mass? This m is mass. Mass is density times volume. Mass is density times volume. But what is volume? What is volume? Is the base area, which is the same as this, A, then times this height. So our volume is area times height. So what is mass? Mass equals density times volume, which is A times H. So what is pressure? This means that pressure equals mg, but m is this, rho A H, then there is a g, then divided by the area, and this is the same area. So pressure equals rho H G, which you normally write as H rho G. This is it. We have got it. It is very wonderful. You can try it when you are alone. You may decide to use this H as a different. Maybe you can call it D, you can call it Y, you can call it X. You can use anything. But I am sure by the end of it all, you'll have to know that pressure equals the depth, the density, and then the acceleration due to gravity G when they are multiplied together. And from here, you can be asked to state the factors on which pressure in liquids depend. And you can see the depth, how deep something is. The depth going downwards, the depth, pressure depends on that. The density, the more dense liquids, the more pressure. Then G, much of the time we shall be taking G as a constant, though you may move from this planet to another one, or even on this earth, the G will be different depending on some conditions, so it can also affect. So therefore we have the three, the H, rho, and the G. I don't want to go far in explaining that. We shall come to that one later. Let's do some mathematics. Some mathematics about this. We call them numerical challenges. Okay? Numerical. Let's go. Calculate the pressure exerted by water. Yes, we want to calculate the pressure exerted by water at a depth of 3.0 meters, and you are given the density of water as 1000 kilograms per cubic meter, and then the acceleration due to gravity G, which is 10 meters per second squared. The important things is the H, the rho, and G, and if you have them, you substitute them there, you automatically get the answer. Let's go. Pressure exerted by water at a depth of 3, meaning H is 3.0 and it is given in meters. The density, the rho, the density is given as 1000 kilograms per cubic meter, and the G is given as 10 meters per square second. So pressure equals H rho G, and this is equal to 3.0 times 1000 times 10, and this is equal to 3 times that is 30,000. The SI unit of pressure. Remember, which one we use? A Pascal or a Newton per meter squared? Okay, that one. Let me use this. A Newton per meter squared. Please mark the way I am writing mine, and before that, we can have another. Example. Yes, the pressure exerted on a diver at a depth of 3.5 meters in a sea is this one. 36,050 Newton per meter squared. Determine the density of sea water. Here you are given pressure. Density is required. Let's see what we have and what we don't have. We have pressure. We are told the pressure exerted on that diver is this much. Is at a depth of 3.5 meters. And of course we know that G is 10, is a constant. So we don't have density. we don't have density. So you can from pressure equals H, rho, and G. We have our pressure here. Substitute 3, 6 equals, what is H? 3.5 times rho, which you don't have, times 10. How do we get rho? Let's divide by 3.5 times 10. Divide by 3.5 times 10. So when you press on your calculator, this divided by that, these ones have cancelled. We have rho equal, we have our rho equal to, do it please. If your answer is the same as mine, we shall move on. Mine is this. And I can decide to use density now. The SI unit of density is a kilogram per meter cubed. This one is giving us the density of sea water. I think I have done a lot. You can also do this. You can. Yes, that the pressure exerted by a liquid P at a depth of 2 meters is 18,000 Newton per meter square. Calculate the density of the liquid. Then after that, the pressure exerted by the same liquid at another depth of 5.0 meters. And then, which liquid is it? The name of the liquid P. Name the liquid. How do you name it? Check its density. Look for the liquid that has that density. You can check from your books. If you don't have, possibly you have it in your head. If you don't get it from there, you can check on the internet. The liquid that has that density that you have acquired in Roman 1. Then after doing this work, don't keep it. Don't keep unmarked work, please. Never do it. You can send it to us. We are not far. We are BAC Science Education Consultants, and we are providing all these services. Be there, subscribe to our channel, and share and like and invite friends so that they can also share, so that all of you keep notified, because we are saying no matter the challenges, learning must continue taking place, and we must reach where we are supposed to reach despite whatever happens. That is it for now. Don't forget to like and share and subscribe to our YouTube channel.